Right, good afternoon everybody. Sorry I can't be there. Um, so last lesson we did this required practical, and this is definitely on the C2 paper. So remember, they've given us a list of the topics and they've given us a list of which required practicals you need to know inside out. So this is one there's definitely questions about on the final paper. So first of all, in a title way, start a new page. The title of the required practical is Rates of Reaction. And what we've done is this first section. Investigate how changes in concentration affect the rate of reaction by measuring the volume of a gas. We haven't yet done the change in colour one here, but actually you can put the title for both for now. So whoever's running the lesson will pause it now and let you write the title. Okay, so moving on. Next thing you need to do is have a diagram. And the main diagram is this one I'm just about to circle here. So what I would like you to do in the next couple of minutes, neatly, pencil and ruler, etc., you're going to draw and label the diagram. So this should be a conical flask. I'll just put CF there for now. I'm just going to put a B next to the bung. This tube, the gas went down, is a delivery tube. I'll put DT for you. This piece of equipment, MC, a measuring cylinder. This one here is a trough. And obviously we were timing it as well, measuring the volume of gas. So don't worry about the instructions on this, just that bit of diagram there in the middle. Pause now and get that done. Okay, so after the diagram, what you need to be able to do, especially for 6-mark questions, is to be able to give the whole of the method. Now I've done it for you here because we did this experiment last lesson. You know what you've done. So really quickly, you set up the gas collection equipment, you measure out the hydrochloric acid using we've already said it a minute ago, put it in the conical flask, measure out the 1 gram of marble chips, add them together, and this is important, you quickly add them together. Because remember how quickly that reaction started when me and George did it. Then you're recording the volume of gas every 15 seconds, repeat it for the other concentrations. We didn't do this because we didn't have time, but what you would normally do is you would repeat the experiment 3 times. Right, this will pause now and you can write out your method in your own words if you can. Okay, so with each of the required practicals, the next sort of sections that you can get asked questions about, you always have to do a risk assessment. So on here, oh, where's that gone? There it is. Risk assessment. In this experiment, we all wore goggles because. So you'll complete that sentence yourself. Why did we wear goggles? You have to take care whenever you're using acid in the classroom and glassware, because if the acid is spilt, right, so what would you do? And so you have to show that you've got some sense there. And then the variables, the independent variable, the one that you change, the dependent variable, the one that you're measuring, and control variables. So again, this will pause, have a go at those. Right, I'm guessing you've paused by now. So let's just check what you've put. Here, if the acid is spilt, the most important thing is that you would clean it up. So I just write clean. Then you would wash your hands and you would wash the desk, because we don't want to leave any of that acid around for anybody else. By washing your hands, you're diluting the acid and making it less harmful. The independent variable, the one that you deliberately changed in this experiment, was the concentration of acid. Hopefully you've all got that yourself. The variable you were measuring was the volume of carbon dioxide gas. And the control variables, what do we deliberately keep the same so that it doesn't interfere with it? We kept the amount, we always use 1 gram, amount of marble chips. What else did we have to keep the same? We deliberately kept the volume of acid. Because we're dealing with a liquid, it's absolutely essential you use the word volume. You don't say amount of acid, you say volume, because volume is something that takes up space, about 50 centimeters cubed. And thirdly, something that could really interfere with this experiment would be temperature. So we'd make sure that all of our acids were at the same temperature. We didn't do it, but it's a good idea sometimes to test them with a thermometer. Right. Whoever's covering the lesson will now pause it so that you can just check your answers against those and make sure they're correct. And then the next thing you need to do is draw out the results table. Now, when you've drawn this out, you have got some results. I know a lot of people didn't get this one done down here, sorry, the 0.25, but I also know that Macy's group did get that done, so maybe she could share her results. But draw out the results table, fill in the results you got for your experiment. Most of you got them into the back of your book somewhere. Okay. Okay, and now the clever bit. So here we have the time of the reaction going on. So you recorded after a certain number of seconds, and here we have the volume of carbon dioxide. And this first one up here, the strong acid, look how fast it started off here. Started off really fast, slowed down because there was less particles, slowed down, and then here it finished. It wasn't releasing any more gas. So you've got to make sure that you can explain that. This one, a much weaker acid, quarter of the strength, starts off much slower. But look at it, it gets to the same end point. So it will eventually get to the same place, but at a much slower rate. So what I would suggest is for this type of graph, I would like you to do a sketch of this and, just like I've just said, explain why this line here is much less steep, a much lower gradient than the 2 molar. Maybe just put the 2 lines on there and forget about that one. Make it easier. So you're sketching it and then you're adding your explanation. This is going to take you probably 3 or 4 minutes to sketch it and 3 or 4 minutes to explain. Okay, I'll pause now. And now what I want you to do is, this is what we talked about in class before we started the practical. Here's our chemicals, the red chemical and the green chemical, and what we got as far as is, for red and green to react, they have to collide. So first of all, they'd have to hit each other. But because there aren't many particles here, this is a low concentration. There's only a few particles, there's a few collisions, a slow rate of reaction. However, over here, when we have a high concentration, we've got much more chance of collisions and a much faster reaction. So what I'd like you to do now is draw the particles for a low and high concentration, and I'd like you to explain the science behind it, those particles colliding. This is more likely to take you about 6 or 7 minutes. Actually, again, it's going to be about 3 or 4 minutes to draw it, then it's going to be 5 minutes to explain. And if we've got as far as this, if time, 3 things here. Chemical companies make everything. So you name a chemical, you name a product in your house, loads of chemical companies. Why would they want to have fast rates of reaction in the first place? What's the advantage to them of having a fast rate of reaction? Question number 2, that was 1. So what concentration would a chemical company use? And number 3, we all know that chlorine is poisonous. Why doesn't it poison swimmers? Explain why. So if you could write the questions and then write your answers to it, that's what I can look at when I'm back. Okay, thank you very much. Now I'll find out some way of pressing pause or stop.